Okay, I think it's time to start. Hi everyone, my name is Patrycja Wegrzynowicz, and today I'm gonna tell you about secure authentication and session management in Java EE. Briefly about myself, I've been doing professional software development for nearly 20 years. I've always been an active developer and I still am, and I must say I love it. I'm the founder and CTO of Unita. Unita is a startup where we aim to bridge the gap between the industry and the academia. In addition to trainings and code reviews, we work on automated tools for detection and refactoring of software defects, including security vulnerabilities, performance anti-patterns, concurrency, and database issues. So basically, security vulnerabilities are my daily job. What am I gonna talk about today? First, a brief introduction to security problems, HTTP and session concept. The key part of today's talk includes 4 demos that illustrate how to hijack the session, how to use HSS to steal the user's session, how to exploit cross-site request forgery to use session without the user's permission or even without his knowledge. Security is important. There's no question. For the last 2 decades, web technologies have experienced significant growth. The number, the complexity, and the size of our software systems have increased substantially. Unsurprisingly, many new techniques to attack IT applications have been developed as well. The years 2014 and 2015 show that pretty well. Who heard about Heartbleed? Yes, almost all of you. Shell shock. Yep, quite a lot of you. Logjam. Logjam has been discovered in 2015, and it's another kind of attack on TLS protocol. So basically, it's against Diffie-Hellman key exchange, which allows to downgrade the TLS communication, and in a result, just to read any transported data. So there is no doubt security is important in today's world. Let's get back to the web. HTTP. HTTP is the foundation of data communication in the World Wide Web. It's a stateless application protocol based on a request-response communication schema. What does it mean, stateless? It means that each request is processed independently. As we think of web application, there is an obvious need for statefulness, right? We must keep track of the user authentication. We must keep track of his interaction with the app to display personalized data. For example, to display only functions that user has permission to keep track of, I don't know, shopping baskets, etc. So how can we achieve that? That's the place where web session comes in handy. A web session identifies interactions with one user. The implementation is simple. We need to associate a unique identifier with every request from the same user. In Java EE, this identifier is named JSessionID and is implemented as a cookie or URL parameter. Everything works great, right? So what's the problem? The problem's here. Broken authentication and session management is number 2 on the list of the top 10 security risks according to OWASP. OWASP stands for Open Web Application Security Project. It's a non-for-profit organization which aims at increasing security awareness among developers. And every 2 or 3 years, OWASP publishes the list of top 10 security vulnerabilities in web applications. It turns out that authentication and session management cause a lot of trouble to software developers. The problem is that we, as developers, rely on a platform. We rely on a session ID as a single mean to identify the user, and we don't protect it carefully enough. So it means that our sessions are very easy targets for hijacking. There are 3 primary types of session attacks. The first one is to steal the user's session ID. The theft can be done by various means, like session ID can be exposed in URL, we can sniff a session ID, monitoring network traffic, we can see it in the server logs, or we can steal it via cross-site scripting. The second type of the session attacks is to fix a session ID and then trick a user to log in with our session ID. The third one is to guess the session ID in cases where the algorithm used to generate a session ID is too weak. Actually, the last one is the least likely in the Java world, but still it can happen. Anyone here who uses Jetty in production? So be careful and take more attention to Jetty session ID because it's pretty short. If it's short, it means it's vulnerable to this kind of attack. Okay, so now I will need your help. The first demo comes in. This is how we can steal. This is about how we can steal session exposed in URL. I will log into my sample application. I will post a link with my session ID on Twitter, and then you can access it, and you will see how easy it is to hijack a session. Okay, my Twitter handle is YonLabs. I'm logging in, and now you can see JSession ID just encoded in URL. So I will post this URL. And then, after you click it, you can reveal my secrets. Okay. We'll see. Yes, we've got another hacker here. You see that he or she uses the same IP address. I guess we both are connected to the conference Wi-Fi, but he or she uses Android and Mozilla. Linux and Mozilla or something like that. User agent is as displayed here. And one here, we've got for more users. We see that they use different IPs, and we see iPhone here and so on. So that's very easy. And basically what happened here. What happened here? It happened that session ID was just in URL. So if you access the same URL with the same session ID, you access the same session as stored on the web server. It was my session, and you accessed it. So that's enough if you use only session ID as a single mean to identify interaction with one user. Think also about all those places you can serve the web, like coffee shops, like during lectures, like conferences. Imagine how easy it is to take a photo of our screens. And you've just seen that's even easier to use the captured session ID later on. So the default behavior of Java web application is that it allows cookies as well as URL rewriting, session ID encoded in URL. Cookies are the first choice, but applications by default falls back on URL rewriting in case of cookies disabled in a browser. So there are two options to disable URL rewriting. We can disable URL rewriting in an app server, and that's the solution which is app server specific. Or we can use a tracking mode, the configuration parameter in WebXML. By setting tracking mode in session config in WebXML to cookie, we disable URL rewriting. This parameter is available since Java EE 6 and Servlet 3.0. Even if we disable URL rewriting, hackers can still eavesdrop users' session IDs. However, now they need to put more effort into it. For example, they can use network monitoring tools or packet sniffing. And once they find out session ID, again, they can use it as a cookie in a very easy way. They can use a plugin or add-on for a browser that enables cookie management, like Cookie Manager for Firefox. They can use an intercepting proxy that allows to modify HTTP requests, like OWASP Z application proxy. Finally, they can write their own code to connect to the application in question. So, do-it-yourself solution. So it's time for another demo. You've already hijacked my session. Now it's time for me to hijack one of yours. I will use two tools, TCP dump for network monitoring and Cookie Manager to change cookie and session ID. The application is almost the same as the last one. I've only changed the tracking mode to cookie and the authentication realm to custom. So now the application allows to log in any non-empty username. Okay. Also, I will log into my server. Okay, I'm already in. I will run TCP dump. And I will post a link to Twitter. Now it's your turn to log in, and I will observe coming proxy, HTTP requests, and will try to catch one of your session IDs, and we'll see whose session I've stolen. Okay, so please click the link, then try to log in, and a non-empty username will work. And I'm looking at some interesting session ID. please try to use the new link, because I see that there are old URLs coming in. Okay, too many. Let's go at the end. Okay. We'll try this one. Here we see cookie. JSession ID is set to this value. I will try to use cookie manager. Okay. Okay, this one. I will try to log in as Patrycja. And then I will change cookie ID for this domain. Hopefully this is the one. And that would be enough. Yes, I've done it. So who has logged in as test? Yes, we've got the winner. So you see that even though we disabled URL rewriting and we've used cookies, still it's pretty easy to get access to session IDs if we have access to any network leg in our route from the client machine to the server machine. So how to avoid exposure, session exposure during transport? Any ideas? Yes, exactly. Elementary, my dear Watson. Encrypt and use HTTPS instead of plain HTTP. So how can we configure that? First, in WebXML, we set up a security constraint to use a transport guarantee set to confidential. Then also in WebXML, we configure the secure flag for cookies. That's important one, because it prohibits browsers from sending cookies over unencrypted channels. We guarantee that cookies will be sent only over HTTPS. This configuration parameter has been introduced in Java EE6. In previous versions, we have to use a custom interceptor to add this flag to a cookie. Why this parameter is so important? Think about all those static resources, which usually are served from HTTP context, right? Without no SSL, just to speed up our performance. So in case if they come from the same domain name, the browsers will send cookie with those requests as well. The request over HTTP just to retrieve static resources. So first of all, we should serve static resources from a different domain context. And secondly, just in case, it's better to configure secure flag for cookies. This way we guarantee that the cookies are sent only over HTTPS. So far, we've made sure that our session ID won't leak during transport. But there are two other places our session ID can be exposed: on the client side and on the server side. On the client side, the typical attack to steal a session ID involves HSS, cross-site scripting, but also beware of malware that is spread via email, browser exploits, or OS exploits. So everything that can access your browser data, it means that it can steal your session ID as well. Usually we don't care so much about the server side, but remember that many attacks are performed by insiders. So it's important to remember not to store our session IDs in logs. We should be aware about secure session replication, although this one is used less and less often, like application server clustering with session replicated among all the servers in a cluster, right? Anyone here who uses such a configuration? Okay. Still, we've got such things in production because, yes, that was one way of scalability and so on. So think about session replication over secure channels. Let's assume that we have secure transport and how to steal a session if secure transport is used. Obviously, client is a soft spot, so we'll attack a client. So another demo. This time, to steal a session, we will use cross-site scripting. We need 3 pieces of code working together. The first one is JavaScript code to steal a cookie. The second one is a servlet that logs down stolen cookies. And the last but not least, there is a vulnerable application that we will exploit via injected JavaScript code. So the more detailed scenario is that, like, I will store malicious JavaScript code in the application. It's sort of an opinion service. It collects opinions about the conference, for example. And then you will log into the vulnerable application and you will see all the opinions, and in the background, your cookies will be sent into my server. And then I will try to use one of your cookies. Wait a moment, please. Okay, we are here. Okay. Obviously, this is an awesome conference. And then we'll use some XSS JavaScript code. As you can see, the code is pretty simple. Here we construct URL, which is my servlet that logs down cookies. We access document.cookie, which just displays session ID. And then we load this URL into image source. This is a trick to bypass same origin policy in browsers, because browsers do not allow to connect to other URLs than the original one from which the application comes from. The exceptions are images and scripts. So this way to connect to the different URL, different domain, we load this URL into image source. Okay, so I will just copy it. Okay, that's my opinion about the conference. Now I will post it to Twitter and you can access it. Okay, so now it's your time to log in, and then you can just access view others' opinions. Oh. Okay, so we have many opinions so far. good that they are so positive. On the other hand, the one about yacht is pretty bizarre, I would say. Okay, we'll see. Anyone has already connected. I will observe my logs on the server. Okay, we have some connections coming in. Okay, so I will use this cookie. And again, I will use cookie manager. Admin. Who's been admin? Yes, we've got another winner. Thank you for your cooperation. I've stolen your session. That was a pleasure. Okay. Okay, so you've seen that the JavaScript to steal a cookie was pretty simple. The only trick was, as I said before, loading URL into image source. It was just to bypass same origin policy. And how can we avoid that kind of attacks? And how can we configure our applications to behave properly and to be safe? One very important flag for cookies is HTTP only. If we set HTTP only to true, it means that JavaScript won't be able to access cookies. So document.cookie will return like empty string. That's not a standard parameter, but still it's supported by most modern browsers. And the funny thing is that the first time it's been introduced, it was like in Internet Explorer. The first time Internet Explorer did something good. And other browsers have accommodated the same policy as well. So that's very important. And still, this parameter in Java EE is available since version 6. Before that, you could use like interceptor just to add this to proxy, just to add it to cookie. Another type of attack is session fixation. I've mentioned that before. The scenario is pretty easy. Hacker opens a web page of a system in a browser, and usually that time a new session is created and initialized on the server, right? So hacker writes down to the session ID. Hacker has access to the computer physically, so it's not a problem just to check out cookie. So he can just write down the session ID and then leaves the browser open. A new user which comes to the same physical computer, physical machine, he or she sees the application already open. The only thing he or she needs is to log in. So the user logs in, and that time hacker can access the session by making use of the previously written down session ID. So to avoid this kind of problem, it's recommended to change the session ID after successful login, more generally after any escalation of privileges. In Java EE7, we have changed session ID method. In previous versions, we could use the pair like http session.invalidate and then get session true. So best practices for secure session management. I've mentioned Jetty and its short session ID, recommended unpredictable session ID, at least of 16 characters, and most Java app servers support it. We need to make use of secure transport and storage of session IDs. So definitely cookies are preferred over URL rewriting. We have to configure cookie flags secure and HTTP only. We should consistently use HTTPS. Remember about static resources. We shouldn't mix HTTP and HTTPS under the same domain cookie path. And we shouldn't use too broad cookie path, because this way we can lead to leaking our cookie over unsecure channels. Session creation and destruction. We should always create new session ID after login. We should obviously have a logout button. And recommended times for session timeouts is like 2 to 5 minutes for critical applications. And for others, it would be enough, like 15 or 30. 30 is default. Think about another problem. How easily it was to use session ID once we get to know it, right? Maybe on the server side, we should have some means to avoid such hijacking. How can we achieve that? The problem was that the session ID was the single mean that identified users' interactions, right? So think about connecting, associating other HTTP headers with session ID. So on the server side, we could store like a fingerprint of the first HTTP request that authenticates the user, and we should check this fingerprint with other requests just to check out whether or not the session is trying to be hijacked. So if the original fingerprint and the next fingerprint differs, don't match, something's going wrong, it's better to invalidate the session just to keep our users safe. So in case of Java EE API and secure authentication, we have two choices, like declarative authentication, implemented using annotation or descriptors, or programmatic authentication. My choice would be programmatic authentication with Java EE, because it's more flexible and allows to configure more advanced flow, like, for example, changing session ID after login, because it's not guaranteed by Java EE that the server must behave that way. And declarative authorization with roles allowed, permit all, and deny all with and WebXML. So we've turned on the HTTP only flag. Now JavaScript code can't access the cookies. What can we do to steal? Oh, maybe not steal, but to make use of our users' sessions. We can still use them using cross-site request forgery. We will exploit cross-site request forgery vulnerability that makes use of a browser feature related to cookie management. Basically, if a browser has a cookie for a given domain name, it will send the cookie over with every request to this domain name, even the requests made from a different tab or a different window. So now it's time for the last demo. It's cross-site request forgery. I will log into the application, and then it will be your turn to log into application, and a non-empty username will work. And then I will send you the attack URL, and your role will be only just to click me button. And then I will check my account balance. Oops. Okay, wait a moment, please. And okay. This is like a simple bank application. This is my account. I have like 1,000 euro here. And, sorry? Oops, sorry. I'm sorry. Okay, so this is a very simple bank application. My balance here is like 1,000 euro. And you will have 1,000 euro by default as well. So, demo 4, cross-site request forgery, and it's your turn to log in. And then, once you are logged in, I will send you a suspicious page where the only thing you will need is clicking the button. So, demo 4 continued. And we'll see what happens. Oh, perfect. I'm so happy. Thank you. But I guess that you've sent it by hand, because it doesn't look like my attack. Okay, this one are the attacks. What happened here? Take a look at the page source. You see here that even though it's a simple button visualized at HTML, underneath it's a form. It's a pre-filled form, which has two fields set to Patrycja, the amount set to 666, and then its action is sending simply session to it's a method post and action exactly as defined in our original form, which is here. Wait a moment. Okay, so exactly this is the form copied, but with pre-filled values. So you see that the browser will send the same cookie with every request to the same domain name, even though it comes from a different tab or a different window. This way, I was able to exploit your cookies and your sessions, and you've sent me some money to my account. So this is a simple cross-site request forgery. And how can we avoid that? Any ideas? Have you ever heard about cross-site request forgery? I guess that most of you might have heard about that, right? And you perfectly know that the the way to protect against cross-site request forgery is to use a unique token associated with every request sent to the server. So by default, most frameworks has this feature turned on. In the old days, like 5 years ago, it was not that popular. But in today's modern framework, most of them has turned it on. But if not, you just need to use like a simple tag or something like that that produces a token for every form. In my application, I've used Java server pages, and by default it has everything turned on. I had to specifically turn it off just to show you the feature. Another thing, it would be interesting for you, we'll go back to cross-site scripting because that one is also interesting. I would like to show you how our opinions JSP looks like. Because that's, again, very common problem with Java JSP programming. If you use $ to print out our parameters or attributes or anything, our values basically. So by default, $ does not escape anything. The problem with cross-site scripting, the previous demo, was that my opinion, which contained JavaScript vulnerable code, was displayed on the user page as it is. So even though it displayed in HTML view only, this is an awesome conference, underneath there was a script tag in page source which has been executed in the background. That's why our session IDs have been sent into the application server and then logged down. So to avoid that, obviously we need to escape everything we print out in our dynamic web pages. Take a look at Java Facelet. It looks exactly the same. We also have $ here to display and print out the value of opinion bin.opinions. And the behavior is, the semantic is completely different because by default in Facelets, all values are escaped. So that's how we can avoid cross-site scripting in Java code. Remember about escaping and remember how to use the concepts and the semantic of underlying web framework. So basically, you see that we can protect. It's always a battle between hackers and developers. We are trying to protect our application the best we can do, and they are trying to hack our applications, and they are pretty good at that. So the other thing, the conclusion is that we are never safe. Nobody's perfect. We all make mistakes. There is no system guarantees and there is no system that guarantees complete safety to its user. We can't guarantee that our applications are 100% safe. All we can do is improve ourselves as developers. That's very popular continuous integration paradigm. Do you use continuous integration in your software development? Yeah. There is continuous integration, there is continuous delivery. I always speak about continuous refactoring. We need to make our code better, but in fact, the fundamental paradigm is continuous learning. So let's keep learning and let's educate ourselves just to become better developer and to make sure our applications are safe. And speaking about learning, in April I'm delivering security trainings for software developers. You are more than welcome to contact me about the case. And that's all for today. Thank you for your cooperation. Now it's time for your questions. Yes?
I have one note about cross-site scripting with the example that you give. Here you use a new image object that made a request to HTTP.
It was, okay, cross-site scripting, yes?
Yes, and you are doing this from HTTPS website.
Yes.
Firefox by default will prevent accessing HTTP URLs from HTTPS website. So Firefox gives us some protection, cross-site scripting in this case, but users can disable this behavior very easily.
Basically, I've used that in Firefox, and yes, there are various protection in browsers. Basically, you can't guarantee that all your users use safe browsers. Plus, you can always tweak cross-site scripting to bypass browsers' policies. So this one may not work, but the next one would work. So it's like if I switch to HTTPS, it would work, right? So yes, it's again like the battle and war between hackers and developers. There are more security protections included in the browsers. Like I mentioned, HTTP only flag, secure flag. They've been introduced just to protect users and to protect on the browser level. But still, you can see that again and again, new types of attacks are discovered and used against our users. So that was a good question, but still I think it could be like bypass, and we can write a code which works around that. Any other questions? Yes?
There is something called device fingerprint or something like that. Have you heard about using it in as a security cookie or something like this?
Actually, no, I'm not familiar with that. So I'm more focusing on software level and what you can do on software level. So, and this presentation was about Java EE support for that.
I think that's pretty much what you mentioned by
Fingerprinting.
detecting the IP and the
Yeah,
browser.
yeah. I can imagine that, but myself, I've never used that, so I can't say anything more. But my guess is that it works exactly the same way. Because it's just a fingerprint we use on the HTTP. In my case, it was on HTTP requests. Any other questions?
Why are security levels sometimes set so low? For example, the Apache Form Authenticator supports changing the session ID after login, but the flag is set to false by default. So if there's a developer using a Form Authenticator, he wouldn't change the session ID on logins.
You know, I'm wondering about the same. because the example you mentioned, it's not the only one. Think about JBoss application server and JMX management console available with a default password and so on. The same case it was about Tomcat and so on and so on. Even in Java EE, you have in WebXML, when you are configuring authorization, and you will use the example from the Oracle side, you will have a problem. Because, for example, there is a subtle nuance about falling back and default HTTP methods, because you have like 7 HTTP methods. In addition to get and post, the most popular ones, you have head. And by default, the head method falls back to get. So if you are protecting your get method with declarative authorization, and you forget about explicitly stating that it applies to head as well, by default, the app server will fall back to get, and it will be a bypass. So there are a lot of such subtle nuances, and it keeps changing. Last, 4 years, we can observe that providers, the companies behind the tools we use, they are keep improving. They are securing their default configurations, but still we have a lot of things to pay attention to. So that's my wonder as well. Any other questions? Okay, so thank you.